As mentioned earlier, the purpose of this presentation is to discuss a little bit about the marketplace and to discuss about the status and the process of populating the marketplace with material from B-WaterSmart. Now, for those who might not be familiar with the marketplace, this is the home page. On the upper side here, you may find the link for somebody who would like to be navigated. So we have the marketplace is a place where we upload information from several projects and has been involved through several projects. And now, with regard to its content, there are three basic, let's say, type of information that can be found there. Though at first, this information that is related to products, software tools that are developed, technologies on the other hand, and the third part is information about case studies. For each of these types, we create different and separate fact sheets where we produce, let's say, a PDF when somebody can find the relevant information. Now, with regard to B-WaterSmart material, we need to make sure that in products we have all the information that is derived in Work Package 3, and this is related to tools. For the technologies, we need to make sure that all the technologies that are applied in the pilots of the B-WaterSmart are included in the technology sections. And as a final step, we need to make sure that the 6 living labs and their fact sheets are included in the case study section. Now, the most tricky one, let's say, is the technology. Here you may see how somebody can be navigating the marketplace into the different technologies. There is an infographic here, and then there is an overview tree when somebody can look for a technology and find its relations. As you may see, here we are referring to circular economy technologies, and we have grouped them in three, let's say, big subdomains. Those are the water-related technologies, the nutrient and material recovery technologies, and the energy recovery. And then the domains are highlighted in blue, and there are also some even smaller subdomains and groups highlighted in blue. And under each subdomain, we have the different technologies that have been, let's say, uploaded throughout the years. This work has started with the next-gen projects, but it's an evolving step. We have also information from Ultimate, and we need to make sure that the technologies from B-WaterSmart will find their way here if they're not already included. So just to give you a better idea, this is a fact sheet of a specific technology. For example, here you may see the reverse osmosis technology. As if you are navigated in the fact sheet, you will see that the descriptions are generic without any specific reference to a place or a time of application. So this is for somebody, for a client that would like to have a look at the information and decide or start considering if this is applicable to their case. So in those factors, we give information about the unique selling points, the capacity, we describe the technology, the flow schemes, the technology requirements and operating conditions for somebody to implement the technologies, the KPIs, we provide motivation for somebody to implement such technology, among other information. Now, we need to make sure that all the B-WaterSmart technologies of Work Package 2 that are applied in the 6 pilots are included in the Water Europe marketplace as generic technologies. So what we have started to do, Bardia has already sent an email requesting to identify which are the missing technology. So we would like the support of all technology providers, possibly supported by the Living Labs, to check if your technology is already listed in the marketplace. Here is an example. In orange, as I said, are the technologies that are listed. We need to identify any missing ones, and if they are, to identify also the position within this, let's say, overview tree to understand in which category or subcategory each technology belongs. And then if there are technologies that are missing, to collect the necessary information in order to properly describe them. This will be done by using some questionnaires that will be shared to you in due time, and then we're going to create the content and upload them in the marketplace. Now, based on your responses that we have received so far, though here you may see some technologies that are already listed, but of course we have identified some missing ones for which we need to let's say, work on a little bit more and create the general fact sheet. There might be cases that some technologies are not properly, let's say, described in the Water Europe marketplace. Then we're going to see and discuss what is the best way, to create fact sheet that best describe each solution. Now, here the work package 2 team tried to match the technologies as described in the description of work here in the left part with how it are described in the Water Europe marketplace. I'm not going to get into detail. With green are the ones that are already there, and we have the confirmation from colleagues that are properly described. And then with the red are the ones that are missing. And with the orange one are the ones that need some more modification, or for those two are cases that we have already identified that this is a missing technology and we have identified the domain that they belong, but we don't have the information that describes the technology per se. Now, moving now to the products. This is the let's say how somebody can explore. For somebody who...
Yeah, can I ask a question? Just
Yes,
quickly.
sure.
In the table that you showed, some of the technologies don't have any categorization. Does that mean that it's missing, needs to still be added, or
Exactly. We haven't received any feedback from colleagues in order to make sure that we have also the information, because honestly I have to admit that I'm not familiar with those let's say technologies, so that is why the Work Package 2 team started to request this information in order to make sure that all the technology are properly described.
Okay, because I see for Flanders, it's completely blank. I'll try to see, because I'm not sure if I was included in email from Bardia, but I'll just check to see, and then I'll try to follow up with them.
But I will send an email again, Raul. I can certainly forward the communications to you, because Bardia leaded this part, because he's in contact with its technology provider.
Yeah, okay, perfect. Thank you.
But the one question, when was this last updated? Because I remember that Bardia sent an email, I think it was a couple of weeks ago, and I responded the same week.
Yes, and I have received your response, Eric, but I'm going to double check. This is something that Franz prepared, but I'm going to double check with you. I think that we have already, the electrodialysis, electrochlorination, SEVAP, I think that those are already included, correct?
Okay, yes.
But I'm going to double check with this again.
Okay, thank you.
Now, with regard to the projects, perhaps somebody who is already familiar with the marketplace, originally, all the tools of B-WaterSmart, because we have already provided this information, were placed in the products, but there has been a change from the Water Europe. So they decided to have there in the most prominent position the tools that are more, let's say, market ready. And since most of our tools are, let's say, research oriented, they have been relocated within the marketplace. So for somebody to access them, they need to go to the EU project, find B-WaterSmart, and under each case, somebody may find the technologies that are applied and their products. So here, for example, you may see the Lisbon Living Lab. I've selected this one because it's the case with let's say, the higher number of tools applied. Here you may see the 6 tools that are being applied in this living lab. Similarly, under each living lab, you may see the ones that are applied in this case. Now, here you may see a typical fact sheet of a tool. Here you may see the Urban Water Cycle Observatory. As I told you, all the tools and the information of the Work Package 3 tools is already online. We have uploaded the information by using the deliverables of Work Package 3, and we have established the links with the case study fact sheet. But the tool owners are kindly asked to check the material again and update the content if they believe that it's needed. For example, if they have done major developments that are not reflected in the fact sheet, they're currently invited to do so. If they do, and we would like to kindly ask them to do this, they should also have in mind that we received a comment from the reviewers in the PO during the review meeting, and they have requested to make it more reader-friendly and customer-oriented. So please, all tool owners, have a look again at the facts that are already online and try to update content. Now, the only missing tool that from the products is the WaterSmart and dashboard, and this is something that ICCS is working on. And after we will have created the fact sheet, we're going to establish the link with all the cases, since this is a tool that is being applied in all living labs. Now, the last fact sheet, as I told you, is the one that is with regard to the case study. There we have created the 6 living lab fact sheets, but there we have only uploaded some initial information and we have only established the links with the tools. So after we will have created also the technologies fact sheet, we would like to kindly ask all living labs to check the content, to update and include additional information in order to document any final lessons learned from tools and the technologies applications, establish the necessary links in order to have, let's say, the complete overview of each living lab. Now, just to give you a better idea, those are the fields and the type of information that is requested in the case study fact sheet, which has to do with the description, some images, to establish the links with the technologies and the tools, to give information about the requirements and conditions that are necessary in order to implement a technology or a tool, the synergistic benefits that come along from different technologies or the technologies from the tools, some facts about the applied technologies, KPIs, lessons learned, and information. So in contrast to the general information that is described in the technology fact sheet, in the case study fact sheet, we are specifically describing the status and the lessons learned and the experience that was gained by the application of the tools as meant to a specific living lab, in a specific case, in a specific time. Now, for this, we also received a comment from the reviewers and the project officers. So when you do this and you provide the information for the case study fact sheets, please have in mind to make it very practical and make sure that you are trying to convey the main message of the project and not to use too technical terms and on that matter. Now, this slide summarizes the 3, let's say, basic steps. We need to make sure that we have updated tools fact sheet. We need to make sure that we have all the technology fact sheets for the technologies that are missing. And finally, we need to make sure that we have all the case study fact sheet created. So for the tool fact sheet, this is something that can be done directly by the tool owners, directly using the online forms of the web. You are a registered user, so please use the forms to upload the material. This can be done anytime, let's say until May, where we have the milestone 32 that needs to be delivered, but it would be better to, let's say, to have, let's say, a new milestone a bit earlier. I mean, let's say 12th of April, since the information is already there. Now, after that, we would like the technology owners to use some Excel or Word forms that will be sent to them and fill in the information about the missing technologies. And this is something that needs to be done by the 26th of April in order for us SCS to have some time to upload the material in the marketplace. Water Europe and the developers of the marketplace have established a different process, to upload that information, and this because they would like to have some data managers and not to have, let's say, directly the users uploading information in the Water Europe marketplace. And after we have all the technologies online, then we are going to create the Living Lab fact sheets. Again, by using some Excel or Word forms. This is something that needs to be collected by 17th of May. And then we're going to have a week to allocate a week to have also the Living Lab fact sheets online. Now, this is the final, let's say, slide where we have presented the timeline, the suggested timeline, and the different steps that need to be followed in order to be able to achieve in time milestone 32. So I would like for you to have a look at it and provide, let's say, any objection or any suggestion. I know that end of May it's a very difficult period, considering that many of work package 2 deliverables are due, but this is also something that needs to be done. We're going to easier the process as much as we can from our side, but I think that it will be helpful that those two run in parallel, because many of the much information that will be included in the deliverables might find its way to the fact sheet and of the technologies and the case study, so the material can be used for both purposes. But in order to be able to proceed with that plan, we would like to kindly ask all colleagues who haven't responded to Barty's email to respond in order to make sure that we will identify any missing technology and plan our next steps. So that is all from my side with regard to this part. I don't know if there are any questions or things that you would like to discuss before we proceed with the other parts. I believe that everything was clear. Now, before I give the floor to Eric regarding the training activity, I'm just going to convey a message from France. Just sharing a bit my screen for a minute. Here you may see the deliverables that are due in the end of May. So we have a request from the Work Package 2 side. If any colleague has some time and is interested in reviewing any of those deliverables, please respond to his email, or if you would like to mention it right now, in order to make sure that we will have the proper number of internal reviewers for this great number of deliverables. So that is from my side. So without any further delay, I would like to ask our colleagues from Setaco, I suppose, to give a presentation about the energy recovery.
Yeah, I will take over. Thank you, Dia. I'm sharing my screen. Can you see my screen?
Yes, not in a presentation mode yet, but we can see it.
Okay.
Great.
Okay, so let's start then. Thank you and welcome everyone for attending this session on energy recovery in wastewater treatment plants through waste gases, which will be focused on a training action on 210 in B-WaterSmart, which is the co-digestion with oil and fats and food waste to improve biogas production. I am Eric Santos. I am the Alicante Living Lab mentor. And just to give a welcome introduction and present the agenda for today's training, we'll have a first presentation on the training regarding the biogas production increase through co-digestion that will be presented by Aida Poveda, who is a R&D technician at Aguas de Alicante, and she, together with Mariano They were involved in the operation of the pilot plant. And then after this presentation, we will include another presentation for the production of cost-effective biomethane, which would be another approach of recovering energy from waste gases in wastewater treatment plants. And this will be presented by my colleague Alejandra Cordova in Zetaqua. Then we will move to a Q&A session for answering any questions that may come up. And we will end up with a conclusion in which I will also share a link, which will be an evaluation survey of this training. And with no further ado, I invite my colleague Aida to share her screen and present first presentation.
Hello. Okay. Okay. Can you see my screen?
Yes.
Okay. So, good morning, everybody. My name is Aida Poveda, and I'm going to present this training entitled Energy Recovery in Wastewater Treatment Plant through Waste Gases. I am an R&D technician in Aguas de Alicante, and along with my colleague Mariano Garcia, we have been in charge of the experimentation of the pilots of the B-WaterSmart project. First of all, I'm going to explain some key concepts in the training: anaerobic digestion and anaerobic co-digestion. The first of these processes, the anaerobic digestion, is the one in which microorganisms, such as bacteria or protozoa, break down organic matter into small molecules in the absence of oxygen and produce biogas. Anaerobic digestion is found naturally as a decomposition process. On the other hand, we have anaerobic co-digestion. This is a mature technology based on the simultaneous management of organic waste from the food or textile industry, among others, together with sewage sludge. In this pilot, we will analyze whether the chosen co-substrates are good for the process, and also observe whether there are any special needs due to pH or inhibitions. To continue, we must understand the context in which we are going to work. In this case, the pilot was installed at the Rincón de León wastewater treatment plant. This plant has a design of has a design flow of 75,000 cubic meters per day. It consists of two treatment lines: the water line with conventional activated sludge treatment, tertiary treatment, and disinfection, and the sludge line with anaerobic digestion, dewatering, and cogeneration. Anaerobic digestion is carried out in two 500 cubic meters digesters and produces 6,000 cubic meters of biogas per day, with a methane richness of 67%. In this context, we must understand the characterization of the sludge that we will be using. As a basic characterization concept, we have pH that is ideally kept at neutral around 6 or 7, and chemical oxygen demand, that is the quantity of oxygen necessary to eliminate the quantity of organic matter present in the wastewater. And volatile solids. This is the food for the microorganisms in the digester. They can be carbohydrates, proteins, and lipids. The removal of the COD and volatile solids gives a ratio of the biodegradability of the substrate that can be translated into biogas production. This ratio is 350 liters of methane produced per kilogram of COD removed. And then as a basic digester design parameters, we have temperature, that is very important to keep it constant in the mesophilic range. This is between 30 and 35 Celsius degrees. And hydraulic retention time is the time needed to digest the sludge. In this table, we can see different parameters of the sludge in Rincón de León. And regarding the characterization of co-substrates, the oil and fats residue from the wastewater treatment plant was taken into account. This waste is obtained as a product of the descending degradation of the inlet water pretreatment. Its management is complicated and expensive, which is why it was initially proposed as a co-substrate. However, characterization studies of this waste showed that they are not highly biodegradable, which makes them unsuitable for co-digestion. And when we used the waste from the fruit and vegetable supplier and the ice cream factory, we obtained different results. First, the ice cream factory, we analyzed two wastes. One was from the cleaning of the machinery, and the other one was from the sewage treatment plant on site. These have a high COD and a high value of volatile solids, and that's why they are a good substrate. The fruit and vegetable waste has a high COD, but not as high as the waste from the ice cream factory. Regardless, it is still a good substrate for co-digestion. The only drawback of this waste is that it needs grinding and homogenization due to its variability and consistency, adding an extra step to the whole process. To sum up, oils and fats are not a feasible option to co-digestion due to its lower volatile solids value, whereas the wastes of ice cream factory and fruit and vegetable are a good option for this pilot. Okay, and nowadays there are a number of laboratory scale studies that are used to ensure the quality of the substrates for co-digestion. Chemical oxygen demand and volatile solid work as an indicator to biogas production. BMPs, biochemical methane production, although these are more expensive but useful, are also a good indicator. We should keep in mind that these experiments are done on laboratory under anaerobic conditions in a batch reactor. The methane is measured after 30 days. And as we can see in this graphic, the biomethane production of ice cream waste is in gray and fruit and vegetable in yellow are higher than the sludge on Rincón de León in green. On the other hand, we can observe that the biomethane production of the cream waste sludge in blue, which is from the wastewater treatment plant of the factory, is lower than other residues. For that reason, once again, the ice cream waste and fruit and vegetables are a good option for co-digestion. And then speaking about the plant operation, we follow the next steps. First, we work with a hydraulic retention time of 25 days. And that implies taking out 44 liters a day of the digester. And then we feed 44 liters a day spaced over time. This is so important to the digester. After that, we measured gas composition with a gas analyzer and recorded the instantaneous gas flow rate and total flow data. Finally, once a week, we took 1 liter of sample from the digester and 1 liter of sample from the feed tank. And now let's take a look at the experiments carried out during this whole study. Firstly, a monodigestion campaign was conducted in order to reproduce the data from Rincón de León, obtaining similar results with the same chemical oxygen demand removal of 50%. In this campaign, we used the same mixed sludge than Rincón de León. Then we experimented a co-digestion campaign of sewage sludge with the two wastes from the ice cream factory, the ice cream waste and the sludge. We found an increase in biogas production from 0.49 to 0.78 liter per minute. Chemical oxygen demand removal was similar to theoretical estimates, and we observed an overproduction of biogas due to the high organic load of the waste.
Sì. Allora, riba.
Sorry. Okay, finally, we executed a co-digestion campaign with fruit and vegetable waste. This campaign was marked by the variability of the co-substrate, which made it difficult to characterize. Regardless, biogas production data of 0.57 liter per minute was obtained, which translates into an improvement in production. And it should be mentioned that we have the objectives in the European Union, backed by an industrial alliance that goes hand in hand with Repower EU. More specifically, in Spain, a roadmap has been drawn up to multiply biogas production by 3.8 times in 2020, which is why we are now working on co-digestion so eagerly. So by the end of this campaign, theoretical studies were made on what the scenarios would be, depending on the availability of the co-substrates. Scenario A shows an improvement from 9.3 to 21% energy self-sufficiency by adding 5% of the co-substrate that is available today. In scenario B, even though we have to know that we're dealing with a theoretical proposal, we could be able to increase self-sufficiency in up to 36%. This would require sufficient quantities of waste to be available. Although the study has not been carried out mixing both wastes, there is no reason to expect negative effects. And now, speaking about legal and commercial considerations, a special license used by the regional government is required for a wastewater treatment plant to become a solid waste manager entity, processing other sources of waste. In addition, waste from animal sources requires additional authorization due to biological hazard consideration. This is where the role of the waste intermediary comes into play. They are in charge of connecting companies with organic waste and companies with co-digestion, making the implementation easier. They carry out the pre-study of the co-substrates, the pretreatment, and handle the transport. Nevertheless, this is an optional figure. And these slides show the specifications and technical requirements that the installations must have for a co-digestion startup. One of the most important things to take into account is to have at least 70% biodegradable substrate and sludge. and an organic load of 60%. On the other hand, it is important to remember that we have to respect the hydraulic retention time to reach good chemical oxygen demand removal results. In addition, some co-substrates require pretreatment, such as fruit and vegetables, which require to be crushed. And to conclude this training, we can say that this experiment was a success, proving co-digestion as a good strategy for the recovery of electrical energy. Also, it gave us a new appreciation of wastes, such as ice cream or fruit and vegetables, which could improve the process of obtaining biogas. And the next steps will be, first of all, the execution of an European project in which pretreatment methods for the improvement of biogas production in co-digestion will be used. In addition, co-digestion will be implemented in the wastewater treatment plant of Monte Orgegia in Alicante, with the waste chosen in the pilot plant. And that's all. Thank you for your attention.
Thank you, Aida. I think that we can keep the questions for the final of the training. So now we can move on to our next presenter, who is Alejandra Cordova, that she will be presenting the biomethane production. So Alejandra, are you around? Yeah.
Yes.
Okay, thank you. The floor is yours.
Hello, Eric. Hi, thank you. Please confirm if you can now see my presentation.
Yeah, we can see it.
Great. So good morning. My name is Alejandra Cordova. As Eric says, I'm project manager at Setaqua and the coordinator of the Sempre Bio project. Thank you for the opportunity to be here today. Sempre Bio is the acronym that stands for Securing Domestic Production and Cost-Effective Biomethane. The objective of the Sempre Bio is to demonstrate novel and cost-effective biomethane production solutions and pathways essential for achieving the European Green Deal and the climate and energy objectives for the 2030 and 2050, as well as to increase the market acceptance of the technologies related to biomethane. Sempre Bio is a 9.9 million euros project funded by the European Union under the Horizon Europe program. It is a 42-month project that started on November of the 22 and will end in April of the 2026. It is made up to 6 countries: Spain, France, Belgium, Germany, and Denmark and Norway, and is integrated by existing partners with different expertise, such as research centers, universities, the industry, end users, a farm, and a consulting agency also, of which Setaqua is the project coordinator. A previous related project that serves as the foundation for one of the case studies in the Sempre Bio project is the Life Nimbus. The project, known as a non-impact bus, aims to showcase the potential of power-to-gas technology through a biological methanation process. Its main objective is to promote circular economy by producing biomethane from sewage sludge and power-to-gas technologies, which can be used as a sustainable fuel for public transportation. Life Nimbus is a 1.9 million euros project co-funded by the LIFE program. It has a duration of 39 months and is set to conclude in October of this year. The project consists of 4 partners and includes a case of study located in Spain. Both projects are located at the El Prat de Llobregat wastewater treatment plant in Barcelona, in Spain, that is operated by Aguas de Barcelona. The plant is structured as a biofactory, which represents a shift from the old paradigm of traditional wastewater treatment plants that's focused only on purifying wastewater to preserve the environment and public health. In the old paradigm, the plant required an imported electricity and generate waste. In contrast, the new paradigm of biofactory aims to achieve a circular model by generating energy, reducing water, recovering waste from the purification of the process. And this approach has a positive impact on society and biodiversity. In both projects, the starting point will be biogas obtained from the anaerobic digestion of the sludge from this urban wastewater treatment plant, resulting in biomethane. Biogas methanation is especially interesting because it valorizes the CO2 from the biogas, being like a decarbonization technology really good. Biogas contains about 35% of CO2 and 65% of methane. Additionally, with small amounts of other gases such nitrogen, hydrogen sulfide, water, and trace amounts of various volatile organic compounds that might also be present. And in a conventional upgrading, it's just the separation of the CO2 from the methane and purifying from the hydrogen sulfide, the siloxanes, and the volatile organic compounds, where the CO2 has difficult valorization, and in the vast majority of the cases, it's directly vented to the atmosphere. But with the implementation of the methanation in both projects, this situation is expected to be resolved by adding hydrogen to the biogas to make the CO2 react to methane through the methanogens. Additionally, biological methanation can increase the amount of biomethane available for sale by between 40 and 80%. The process begins with the pre-treatment of the biogas stream producing the anaerobic digestion of the wastewater treatment plant sludge. And to remove contaminants such as hydrogen sulfide, volatile organic compounds, and siloxanes, we need to ensure that we have a clean biogas for the feed. This purified biogas is then introduced in the reactor where it's mixed with the hydrogen gas. The hydrogen necessary to maintain the biogas is supplied by an on-site electrolyzer powered by renewable electricity, where the regenerated water from the tertiary system of the wastewater treatment plant will be pumped through the reverse osmosis systems to generate the mineralized water for the electrolyzer. The produced biomethane then will be compressed for storage and subsequent use in the buses of the public transportation system of Barcelona. Other uses of the biomethane are like electricity generation, injection to the gas grid, and also to industrial applications. Regarding the demo plants, we can see that the Live Nimbus has been operating since last year. We have all the plant in construction already, and it's working and it's operating. And we are at the stage of optimizing the results of the biomethane produced. And while in the Sempre Bio, it's currently under engineering design and also in construction. Focusing on the Sempre Bio, we established 3 European biomethane innovation ecosystems that are representative of the different configurations across Europe. And we have here 3 case of studies that will be placed at the Bio-Brigade in Spain, in Bourges in France, and in Dunkerque in Belgium, where 5 different technologies will be tested. This EBIS, as we call it, will facilitate a long-term replication, creating an active flow of information, and this information will create future investments opportunities. In case study number 1, I already explained it. Well, it's placed at the Bio-Brigade, the wastewater treatment plant, and will demonstrate the biomethane production technologies that will allow the valorization of the current biogas stream generated in the wastewater treatment plant. In the case study number 2 in Bourges, France, is placed at the Ecopole de Marmagne site, will produce biomethane from non-digestible urban green waste. Pilot biomethane production plant will be built and operate from wood biomass and also organic biomass from the city of Bourges. The innovative transformation of wood biomass to biogas will be carried out through the pyrolysis and the methanation technologies, where the wood waste undergoes a pyrolysis process, producing pyrolysis gas, biol, and biochar. And this pyrolysis gas then is cleaned to syngas. The syngas is the one who is injected into the biomethanation reactor to produce biogas. And this biogas will then be mixed with the biogas from the anaerobic digestion that is already placed at the site, and then will be upgraded to biomethane for injection into the network using existing facilities. Last, it's our case study number 3 in Andinkerke in Belgium. And here is a specific case because it's a farm without natural gas connections and low biogas production. These characteristics make it impossible for small biogas producers to have a sustainable production. That is why these novel solutions will be demonstrated that they bring profitability to these small scale plants through biogas purification and liquid biomethane production. Here we will produce liquid biomethane and that will be stored locally, while different ways to valorize the CO2, such in polymers or in proteins, will be studied. The aim of the operator here is to feed almost at exclusive the co-fermentation with manure and only a limited portion of biological organic waste to optimize the process. With this fermentation installation, the farm will be energy neutral. And the goal is to demonstrate the potential of the low scales to produce liquid biomethane and liquid CO2 from biogas with an integrated cleaning process. And the selected technology is through a cryoseparation process. In the expected results of this project, we have 4 expected results. The first one is to increase the cost effectiveness of the conversion in biomethane production. And this is going to be through the optimization of the biomethane production, the economy of scale in biogas, upgrading in small plants, increasing the type and the volume of the raw material from the different scenarios. Second one is the diversify the conversion technologies for biomethane. We have here 3 cases of studies where different technologies will be tested from different also raw materials that are currently unrepresented in biomethane production, but show a high biomass potential in Europe. The third one is to contribute to the acceptance of biomethane technologies in the gas market. And this will be thanks to the techno-economic study of these 3 cases of studies working in our work package 5. That is an important tool for interested for our stakeholders, as well as in the experience of the public and the private sector, and also for our 16 partners to make up this consortium. And last is the contribute to demonstrate the semi-industrial scale of new conversion technologies to produce biomethane from wastewater, from wood biomass, and for manure. And finally, in our expected impacts is, of course, having a more efficient and cleaner and sustainable energy source, as well as safer. And here we have like the biomethane as a substitute for imported liquid natural gas. Biomethane, we know that biomethane has a calorific power equivalent to natural gas. And just to give some data here, for example, in the 2020, 81.6 million tons of liquid natural gas were imported. So the idea is to replace like around the 30% with biomethane in line with the European 2050 targets. Also, biomethane as a substitute for fuel in transport. So we know if biomethane, specifically liquid biomethane, reaches competitive prices, its use as a transport fuel can be extended, serving as a substitute for oil-based fuels and reducing the primary energy demand. Another one is the reduction of the CO2 by 213 million tons a year by the 2050. And with this, we will have to reduce the European emissions by 8.3 compared to the 2020. Another one is that diversify the energy sources and the new routes. And this reduce dependence on fossil fuels from foreign producers, especially Russia, and through local production of biomethane. And with this is that we have also to reduce the need for strategic reserves, and this is because the biomethane and the renewable gases are not subject to have a minimum stocks requirements by the European directrices. So the substitution of natural gas with biomethane can contribute to reducing these minimum natural gas reserves required and thus reduce the cost of maintaining them. And finally is the lex extension of critical infrastructure to protect, because by promoting local circular projects with short distances between the gas production and the consumption, reduce the surveillance of kilometers of pipelines that it have in the infrastructure. Well, that's it. Thank you for your attention. I also invite you to follow our project on the different social media and the platforms for more updates and insights. Thank you.